Today we're going to be doing some more practice with these, but we're putting the 3 times the 2 and the 7. If you can do this, please write this down so you have it. So all of these are being multiplied. So there's like a multiplication sign between all of these, and so we can just put all of our numbers first. So 6 times negative 6 times 7, if we want to think of it, gives us the negative 42. Then we are looking at times, and we are looking at all of those F powers. So as I look on page 41, the next thing that I want to look at is at F to the 2, and notice that I broke that in as F to the first. So sometimes people don't do that. The other thing, all of these exponents are really 1, so that's why we can just multiply them. We don't have to square anything or cube it. Okay? We have F to the second, F to the 1, and F to the second. So when we add those together, we're going to end up with F to the fifth. As we look at our powers of G, as you are looking at those, same thing, I write down what all those exponents are. So I had a negative 2 for the first G, then I write G to the first and G to the negative 2, which leaves me with G to the negative, in this case, 3. I can't have a negative exponent in my answer. So at this point, all of this is kind of like over 1. So the 42, if we think about that, that's negative 42 to the first power. Can't move it. So the question always comes up, but can't I take and move because it's a negative 42, shouldn't I move it? The exponent up here is positive, so we keep it. We're going to have the F to the fifth, and since G was negative, we take the reciprocal, and it goes down here as G to the third. As you look at this, any others that I could look at, I want to see both like 12 and, which other one was it? 12 and kind of 12 and 13 gave a lot of people problems. And my hint would be, when you're looking at 12 and 13, is that in your denominator you have the same base. So we are going to be taking x, and we are taking 4 plus negative 9. And if I add 4 plus negative 9, I get x to the negative 5 in my denominator. But I can't have a negative exponent, so now I have to take the reciprocal. So what happens if it's in the denominator, we're now going to move it to the numerator, x to the fifth over 1, or just x to the fifth, okay? So make sure it's super easy. The ones that are to the what power? 0, right? So I already got the first one, right? I kind of take a look. What's another one that I want to look at? 7, 9, right? So all of these are kind of my easy ones, right? Any other ones? 11 has it as part of it. 16 has a 0 to the 0 power, right? As we are looking at those. 17 has a 0 power. As you take a look at the second page, as you are kind of taking a look at that second page, questions like 25, as we are looking at those, take a look at 25 through 30, right? So they get looking a little harder, but these aren't bad questions. So again, on that first page, let's take a look. And number 3. Number 3, yeah, the 4 in the numerator is to what power if there's no exponent? 1. So please put that in. Any number, if there is no, or any variable, there's no exponent, remember it's to the first power. So I have 4 to the 1 divided by 4 to the negative 2. I'm going to rewrite this as 4 to the 1 times, I got to do the reciprocal, which means I am going to do what with that 4 to the negative 2 in our denominator? I'm going to move it to the numerator and get 4 to the second. Here is the biggest mistake. I'll have my algebra students do the same mistake. They'll say 4 to the first times 4 to the second is 16 to the third. It is not. The rule says when we multiply, you keep the base the same. So the biggest mistake is people go, yeah, but 4 times 4 is 16. Yes, but when it was x to the first times x to the second, we didn't change this from x. We kept it as x and put it to the third power. It's the same thing, it's just a number, okay? So when I look at that one, this is probably the biggest mistake. Now you're going to use your calculator. You want to put these in your calculator because they look for you to simplify. So could you do, not 4 times 3, right, but 4 raised to the third power. 4 times 4 times 4, if you want to put it in that way. The other thing, remember, you can use this on your calculator, this caret key. Some of you have a y to the x on your calculator, to the third and equal, and 4 to the third comes out to equal. Those of you that have your calculator was 64. So my answer to number 3 is 64. I should see this work before. I should see that you made it a positive exponent, right, as you are looking at that, okay? So let's take a look at like number 11. Number 11 had that 0 power. Again, if you have negative exponents, put it over 1. So when you're looking at your homework, and you're going to be working with your shoulder partners on these as you're working on it, you're going to kind of take a look at this and you go, okay, 7 is to the what power? There's no exponent. 1. W negative 2, or V negative 2, W 0. So should I move the 7? No. Should I move the V? No. Yeah. It's a negative exponent. Yes, gotta move the V. It has to go down to the denominator, V to the second. And W to the 0 is the same as? We have V to the third. Oh, is it negative 3? Yeah. Oh yeah, mine is 2. V to the third. So, 7 times 1. I'm going to leave my answer as simplest form, 7, V to the third. If you think of simplest form, it's getting the least amount or not repeating the variable. It's kind of like if you had to, if you were text messaging and you were charged for every little thing you put in there, right? You'd want to do less and less, right? So that's why when phones came out, people had kind of a lot of abbreviated things they would